All right, hello everybody, this is Ms. Pikarski. This is the first review video I'm doing for the arithmetic sequence and series test that we're going to take on Friday. The questions I took straight out of the textbook, pages 17 and 18 in the textbook. So if you want to go through those pages, you can. I will tell you I've changed the numbers and I've kind of changed some of the question formats, but it's all the same question. In the textbook, a lot of them are not multiple choice, and so I've converted it to have multiple choice. In this review, you'll notice that there's only a few questions that are multiple choice. Just know that when you are taking the test, every question will have multiple choice. All right, so let's go through the review, and I will tell you I'm also working backwards. So the very last question in the test is the first one I'm going to review in this video. We are going to have a review in class on Thursday. I just don't know how far we'll get in the review. So you can watch the video and go through all the questions that we haven't gotten to in the class. And then if you want to watch the other questions that we've already done, I guess you can, but you can stop the video if you don't feel like watching them again. All right, so let's go ahead and get started. So the first question we have is find the sum of 1 plus 6 plus 11 plus ... plus 99. So we don't know how many terms we're missing here. And so this is just the first question, and it seems pretty easy because it's just multiple choice. But there are a couple steps to find this answer that we have to do first. The first thing is we've got to come up with a expression or a arithmetic sequence formula so that we can add up all the terms, okay? And so in the test, first I'm going to ask you what formula or what expression will we give you the following sequence. So notice that over here my terms are 1, 6, 11, and 96. But here I only give you the first three terms. This is enough so that you can find the formula, okay? And notice I have a lot of different options here. If you remember correctly, to find your formula, you need your a sub 1, so your first term, which in this case happens to be a 1, and you need your common difference. Well, the common difference is that you're adding 5. So 1 plus 5 gives you 6, 6 plus 5 gives you 11, and so on. So we would have 1 minus 5, and then plus n minus 1. Notice here I have n plus 1. That is not the same thing as n minus 1. So obviously it's not going to be this option here. That's the wrong option. Okay, I don't want that one. So I need to go ahead and there's no other ones where it has, oh my gosh, that's another thing. I have a minus sign there. I want a positive. So I want a plus sign here, but I want a minus sign here. Okay, this one's not the right answer, and this one is not the right answer. For the review, I just need to remember not to save this program. Whoa, what am I doing? I'm going to go ahead and delete the wrong answer. So I know that those are the wrong answers. Now, if I go ahead and simplify it, so right now I know it would be a 1 plus 5 times n minus 1. I know that was the right answer, but that was not one of the answer choices. So I need to see, is my answer choice going to be this one or this one? Well, when I simplify my expression, I will multiply everything here by 5. So I'd have 5n minus 5. 1 minus 5 gives you negative 4. So this would end up being the correct answer choice. Now we're going to use this sequence formula to figure out the following answer. Use your answer from 3.1 and sigma notation to find the sum of 1 plus 6 plus 11 plus all the intermittent terms, and then finally plus 99. And then it says shows your work on the right. Let's see. So it says sigma notation, so I'm going to pull up my sigma notation. I know that I want to have some value, just some variable there. In this case, I'm picking g. And then I'm going to start on my first term. And then here, I'm going to use the formula from here. So 5n minus 4 okay? 5n minus 4, and then up here, I have no idea how many terms I have. I have no clue. I haven't the faintest idea. So I'm kind of stuck here because I don't know what number to put here. Well, let's just guess. I'm going to throw out any number, and I have no idea if that's the correct one. Oops, what did I do? I made the mistake that a lot of people did, and I changed. I had a G here and an N here. I need to put a G. Okay. Honestly, I have no idea if that's the right answer because I don't know how many terms I'm missing here. So I'm going to show you a secret way. It's not a secret, it's just another way to figure out how many terms are in my sequence. Okay, so go to dictionary, this little dictionary thing, and SEQ. If you don't get SEQ popped up right away, you can just type an S and it will take you to the first term that starts with S, and then you can scroll down to the SEQs. So SEQ stands for sequence. So I'm going to put a formula in here, and I'm going to have the calculator give me all the terms of a sequence. So the terms of the sequence, so what I need to put in this parentheses, and I will probably show this to you guys too on Wednesday, is I'm going to put my formula here. Okay, that's the first thing that goes right here. So I'm just going to do 5g minus 4. Okay, then I need to put a comma, and then I need to tell the calculator what my variable is. In this case, it's a g. Then I need to tell the calculator which term do I want to start with. Well, I want to start with the first term, and what term do I want to stop with? I have no idea which term, so I'm going to just pick a big number. Let's say 30, okay? And then I need to tell it what step, so I want it to count by ones. And then here's my sequence. Okay, let me make this a little bit bigger. Oh, no, that's not what I want to do. There we go. All right, so now I can look at my terms in my sequence, and I can go all the way down, and I'm looking for when I get to 96. Well, here's 96 here. So that's the term I'm looking for. And I put, let's see, what did I put? I put 35, didn't I? Nope, 30. So I had 30 terms, and now I can do two things. I can count how many extra terms I have, and it looks like, holy cow, I have a whole lot of extra terms. So I know 30 is too many terms, so let's go up again. Instead of 30, maybe 20. Okay? And again, I get all the sequences. I'm going to go down and see when do I get to 99. Whoops, I don't even get to 99. Look at that. So, oh, what am I thinking? I need 96. So I put a 20 in this sequence. So I told the calculator to give me the first 20 terms, and 96 was the 20th term. So now I know, hey, I'm adding together 20 different terms here. Okay, so I don't want that. Delete. No. Hold on, guys. Sorry. I'm just deleting this. So now I know that I have 20 terms in my sequence. I'm going to go back up to my sigma notation, and I'm going to tell the calculator to add up all the terms from the first term to the 20th term. Then I push enter, and it tells me 970. Okay, so I can click 970. All right, so problem 13 is, there's a lot of steps to it. It seems like an easy question here, but there are several steps to it. All right, let's look at our next question. Let's see, we've got a problem situation here. Let's see. All right, so the number of seats in the first 3 rows of the MIU theater is given in the table below. So here's our table. The theater has 26 rows of seats, and the pattern in the table continues for all of the rows. Write an expression for the total number of seats in the first n rows and use this expression to calculate the seat capacity of the theater. All right, so let's look at the test or the review. There are several parts to this. Again, I just have the exact same thing here. So let's go through all the different questions. And in these questions, basically, I just break it down step by step. And you'll notice these are not multiple choice, but you will have multiple choice options on the test. All right, so now we want to write an expression for S sub n, the number of seats in the nth row. Simplify your expression. All right, so what it's asking for, it's not asking for the total number of seats in the whole theater. It's just asking for how many seats in the nth row. So that's just going to be your sequence formula. Okay, so you're going to have S sub n here, and then it's going to equal your the number of seats in your first row, so 18, plus your common difference. So let's look at the common difference. It looks like you're increasing by 2. Whoops. Common difference of 2, and then times n minus 1. Okay? So that's the sequence formula, but it says to simplify our expression. So we can't just leave it like that. We have to go ahead and distribute the 2 and then combine like terms. And what we will end up getting is, let's see, so 2n, and then we'll have 18 minus 2, so it would be 2n plus 16. Okay? So the S sub n is going to be equal to 2n plus 16. Now we want to find out how many seats are in the last row. Well, let's go over here. How many seats do we have in total? We have 26, we have 20. How many rows do we have? We have 26 rows. So I'm going to use this equation that I just got, but I'm going to set that equal to S sub 26. Why am I putting a 26 there? Because I'm looking for the number of seats in the 26th row, which means I'm going to change this n to a 26. Okay? So I'm going to pull up my calculator, and I'm going to say 2 times 26 plus 16. That was our equation, right? I believe so. Let's look back at the equation. Yeah. 2 times 26 plus 16. So my answer is 68. All right, so the number of seats in the last row is 68. We've gotten that. Now, write an expression for T sub n. The total number of seats in the first n rows. Do not simplify our expression. Okay, so this time, did they say anything about sigma notation? Okay, I know earlier in class I've said read the question and it'll give you kind of clues on whether you want to use the sigma notation or the series formula. Because they say an expression right here, we want to use the series formula. All right, and then for the series formula, we need to, we're going to do T for total sub n is going to equal, hold on, let's change that n to a 26 because we know that there are 26 seats, or excuse me, 26 rows in the theater, and that's not going to be times. That's going to be, the rest of the series formula will be n, which is 26, divided by 2, and then in parentheses, it would be our first row, 18. 18 plus the number of seats in our last row. Let's look back at here. We had 68 seats in our last row. Okay. And yeah. All right. So this is the equation right here. All right. And then what I want to do, this is a series equation here that I'm going to use in 12.4 to actually calculate how many seats are in that last row. So we said 26 divided by 2, right? times 18, which is the number of seats in my first row, plus 64. And let me check and make sure I have that formula right. 68. 18 plus 68. Okay. And then I push enter, and the calculator tells me there's 1,118 seats. All right. So again, this is another question where in the book it looks like, hey, no problem, it's just one little question, but we had 4 different parts to that one little question. There was 4 different steps so that we could finally find the right answer. Okay, let's go on. Hold on. There we go. All right, now, next question. That's the other one. Yes. All right, here's another one. And actually, this one, they do break down the questions into different parts. Okay, we have Claire and Jeremy are reading the same 240-page book. Claire has read 72 pages, and Jeremy has read 90 pages. On Monday, Claire begins to read 12 pages per day. So that sounds like a common difference there. And the 72 and the 90, those are your initial values. Okay, and then Jeremy continues to read 10 pages per day. All right, so write equations for this sequence, C sub n, so the total number that represents how many total pages Claire and Jeremy have read in n days after Sunday. So C sub n is going to be for Claire's reading, and G sub n is for Jeremy's reading. Okay, so let's go on to the next tab. What does C sub n equal? All right, so we know that we want the sequence formula. And we know that with Claire, she read 72 pages was her A sub n, A sub 1. So the formula for Claire would be 70, did I say 71? 72 pages. So her initial value was 72. Plus, how many did she read each day? The common difference was 12 for Claire. There. 12 times n minus 1. Okay. And notice we're just finding the formula. But again, you can simplify this equation. Okay, go ahead and distribute the 12 and subtract. So this would just be 12 times n plus, 72 minus 12 would be what, 60, right guys? I'm doing this in my head. If I'm wrong, let me know tomorrow. All right, so this is the simplified formula for Claire. This is the formula when you first lay it out, when you first plug everything in. All right, so now let's work on Jeremy's formula. Let's see, Jeremy had 90 pages and he's reading 10 pages per day. So Jeremy's formula would be 90 plus the common difference of 10 times n minus 1. And then when I simplify it, it would be 10 times n plus what's 90 minus 10 would be 80. Okay, so there's our 2 formulas. Now what do we need to do? In this context, what should be the value of the last term of each sequence? Well, if they're reading the book and we want to know, let's see, the last term of the sequence, well, they can't read more pages than there's actually in the book. So there's only 240 pages. So in this problem situation, the last term should equal 240. Okay. How many days does it take Claire to finish the book? Well, that looks like we just need to find what A sub n is when our answer is 240. So, let's see. How do we want to answer this? Let's see. Again, we're using our sequence formulas. You know what? Let's just use the sequence formula I showed you earlier. Okay, so I'm looking for how long it takes Claire to read the book. Let's go to our calculator page. Let's clear what's already in there. And again, pull up the sequence. SEQ, and then in parentheses, let's put Claire's formula in there, but we forgot it, so let's look at it. Claire's formula is this page. So 12n plus 60. So we're going to do 12 times n plus 60, not 50, 60. Okay, comma, we need to tell the calculator what our variable is. It's n. And I don't know how many terms or how many days it's going to take her, so I'm going to tell the calculator start for the first day, and let's go to the 20th day. Okay, and we want to look for the number 240. Okay, so let's look at this sequence. So first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. 180 is the 10th day. 11th, 12th, 13th, 14th, 15th. Up, 240 is my 15th day. So all I did is I counted all the terms. So let's go back to our problem. Let's see right here. How many days does it take Claire to finish the book? 15. Since it took us 15 terms to get to 240. Now we want to know how many days does it take Jeremy to finish the book. Same kind of process. Again, but we need to use Jeremy's formula. So 10n plus 80. Okay. I'm going to do up arrow. Same kind of thing. I'm just going to change my numbers. I have 10n plus 80. Is that correct? Let's look at it. Yep, 10n plus 80. And since it took Claire 15 days, it'll probably take Jeremy right around 15, maybe 16 or 17 days because he's reading fewer pages per day. So let's see. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so on the 16th day, Jeremy will be done with the book. All right, let's go ahead and close that. So we know our answer. It's going to take Jeremy 16 more days of reading. Okay? All right, so we are done with that question. How many terms does each sequence have? How does this relate to who finished reading the book first? Okay, in this case, Claire read the book one day before, or finished the book one day before Jeremy. All right, now here's the next question. This should be an easy question. Let's see. Yeah, I want it all by itself. All right, write the sequence of the first 6 partial sums of the sequence 3n minus 4, where n equals 1, 2, and 3. Okay, so this is one of the activities we did in class on Tuesday. Let's go ahead and go to the correct question. This one seems like a pretty easy one. Okay, when we were working on this in class, we used sigma notation, and we used sigma notation because we knew we did not know what our a sub 1 and our a sub n was. Okay, so in the calculator on the right, I'm going to show my work, and I want to use, let's see, what letter should I use this time? I'll use W. W is my variable this time. I'm going to start with my first term. I'm going to put my sequence formula in this box, the 3n minus 4, and write the sequence of the first 6 partial sums. Okay, so I want to know what is a S sub 1. Okay, my first sum from the first term to the first term. Okay, and then, oops, dang it, I did it again. What did I do wrong, guys? I put an N here instead of a W. Whoops, W. There we go. Make sure your variables match. All right, so my first series of just the first term is -1. Okay. Now I need to find the second term. Okay, and the only thing I'm going to change is this one on top. I'm changing it to a 2. Okay, and that gives me a 1. So I have a -1 and a 1. Okay, now my third sequence or series, if I add together the first 3 terms, gives me a 6. And then if I add the first 4 terms together, gives me 14. So I'm going to go ahead and add that onto the pattern. So 6, comma 14. And then I think I need 2 more. So 5 and 6, right? Change that to a 5. And then go up again, copy and paste it, and change that to a 6. So I have my last 2 numbers are 25 and 39. Okay, so those are the partial sums right there. Hopefully we remember how to do that. Okay, now, there we go. I want each question all by itself. There we go. All right, hopefully we remember how to plug this into the calculator, evaluate the sigma notation. Okay, that seems like an easy one. And right here, let's see, same problem, yep. The nice thing is this problem has the parentheses all laid out for us. Just remember, if there's no parentheses, then we would do the J3 in the parentheses and the +4 would be on its own. Okay. Please show your work over here, all right? That way I know if you just got answers from somebody else, which, it's not going to help you to get the answers from somebody else. All right, so right here, all I have to do, guys, this is like this super easy problem. I shouldn't have anybody miss this problem because all I'm doing is typing in exactly what I see over here. That's all I have to do. I can't believe the workbook gave you this problem to solve. And that's it, 65. There we go. All right, that one's a super easy problem to solve. I wish all of the problems were that easy. All right, next one. Find the sum of the first 20 terms of the arithmetic sequence 27, 30, 22, and 17. Here we go with another one that probably has a couple parts to it. Oh, hold on. Find the sum of the first 20 terms of the arithmetic sequence 17, 22, and 27, 22, and 17. Show your work on the right. All right, well, first, I will tell you it'll probably be easiest to use sigma notation, but we could use the series formula if we knew what the 20th term was. But in order to find the 20th term, we have to first find the sequence formula. If we're going to find the sequence formula, we might as well use the sigma notation. So honestly, it's up to you on whether you want to use sigma notation or the series formula. In fact, what I will probably do is show you how to find this answer with both formulas. All right. So first, let's use sigma notation. All right. So with sigma notation, let's pick a variable. We pick b this time. We want to start with the first term. We want to finish with the 20th term. Now we've just got to figure out what sequence formula are we going to plug in here. Well, just type out the sequence formula, guys. I know my first term is 27, so it'll be a sub 1, or 27, plus whatever my common difference is. And in this case, it looks like I'm decreasing by 5, so I need to get rid of that plus sign and put a -5, and then in parentheses, n minus 1. Okay? Close parentheses. There we go. All right, so if I was going to use sigma notation, that's what I would do. Oh, dang it, man. Every single time it's biting me in the butt. Holy cow. One of these times during the review, I will get it right. I will put the correct variable here, I promise. At least once. All right, so this is telling me that my correct answer is -410. So now let's say, hey, I'm not too familiar with sigma notation. I want to go ahead and use the series formula. So to find the series formula, first I have to have my first term, which is 27. I know that. But then I have to find my last term. So I need to know what is 27 minus 5 times 20 minus 1. And most of you are like, wait, where did the 20 come from? Well, I'm counting, or I'm adding together the first 20 terms. So my last term is going to be the 20th term. So that's where that 20 comes from. Okay, so I know that my last term is negative 68. Now I'm going to set up the series formula. With the series formula, you have your fraction of n divided by 2. And in this case, n is 20. Okay, divided by 2. And then parentheses, my a sub 1, which is 27, plus my a sub n. And in this case, my a sub n is negative 68. Okay, and then I close parentheses. All right, so notice for my series formula, if I use my series formula, I get negative 410. If I use my sigma notation, I still get 410, or negative 410. So both cases, whichever method I use, I still get the same correct answer, 410. All righty. Rewrite the following series using sigma notation. Oops, I don't want to look at that problem yet. All right, I want to see one problem at a time. All right, so I'm doing sigma notation, same kind of thing I've already been doing. I need to find my first term, and I need to know how many terms I have. That's going to be my n value. I need to know my d value. So just by looking at this right now, let me go ahead and work it out in this, and then I'll move over to the other formula equation. There we go. So right now I know that, let me find my subscript thing. There we go. I know that a sub 1 equals 27. I know that d equals, let's see, 27 plus 22. Okay, so my first term is 27, my second term is 22, so I'm decreasing by 5. So d equals, the common difference is negative 5, and I know that my last term, my a sub, which term is this? First, second, third, fourth, fifth, sixth. So I have 6 terms, and my last term is equal to 2. Okay? Now I can set up my series, or my sequence formula. Let's see. I need to escape out of that. Let's go to this one. All right, so rewrite the following series using arithmetic series formula. Do not simplify your formula. Let's see. So this problem asks you to just rewrite it using sigma notation. I would like you to be able to do both. I want you to be able to set it up as a series with the series formula and the sigma notation. So in here, the first part, they want the series formula. So I'm going to use my subscripts. And we're going to say S sub n equals, and then we need, let's see, a sub 1. Let me make that bigger. All right. Sorry about this. All right, so my initial term, no, series formula, I need my n value. N is 6, so it'd be 6 divided by 2 times my a sub 1, which is 27, plus my a sub 6, my last term, which is 2. Okay? So that's how I'd set it up with the series formula. Notice it does not say to find your answer or solve it. They just want to know, can you set up the equation? Okay, let's go down to the bottom question. In the bottom question, they want us to use the same sequence or same series numbers and just add them all together, but use sigma notation. Okay. With the sigma notation, let's see. I'm going to move this up some right there. All right. So now I have a little bit more space here because the sigma notation takes up a lot of space, doesn't it, guys? Okay. Now we need, let's pick y for our variable. 1. My last term we said was 6, so the 6th term. And then I just need the sequence formula, not the series formula. Okay. Remember, we do not use this formula in this box. It is not the way it works. Okay, we need to use the the sequence formula, which is your first term, a sub 1, plus your common difference. In this case, it's -5, so we'll do -5 times n minus 1 and close parentheses. Now, what happens if you start taking the test and it says simplify your expression? Okay, if it says simplify your expression, then you want to go ahead and I'm going to see if I can copy and paste this. Copy, Control V to paste. All right, so the only thing we're simplifying is this part. It's still going to be -5n, but then it's going to be, we have too many parentheses. Let me get rid of the extra parentheses. And then positive 27 plus 5. So -5 times -1 gives you a +5. So 27 plus 5 would be, I'm trying to do this in my head, I want to say 33. If I'm wrong, guys, let me know in the morning. No, that should be 32, not 33. 32. There we go. So either one of those, but if it says simplify your formula, which it does right up here, then you need to go ahead and simplify this equation, okay? Make sure you know how to set up the series formula and the sigma notation. All right, next question. Arithmetic sequence with a sub 1 equals 3 and d equals 2.4 contains each term below except. So I need to figure out which term does not belong. There's some really big terms there. So, you know what? Let's do a cheat. You're not allowed to tell your geometry teachers or your college algebra teacher that I showed you how to do this. So I want to see my work right next to me, so I'm going to include a calculator over here. And I'm just going to tell the calculator to give me this sequence. Okay, notice here, all I'm doing is I typed in the word SEQ. If I don't feel like finding the words SEQ here, I can just type it in as well. The calculator understands that's what I mean, and it even gave us the parentheses. All right, so sequence, and I want it to tell me the terms in the sequence. However, I don't know what the formula is yet, do I? So let me see. Oh, you know what? It had me do the formula up here. Remember I said in your test I'm going to break down the questions into steps. So the textbook just gives you this question. I'm going to have you figure out the formula and then use it. Okay, so let's figure out this formula. It would be a sub n for my sequence formula. So a sub n is equal to my first term, which is 3, plus my common difference, 2.4 times, excuse me, n minus 1, close parentheses. Notice it does say simplify your equation. So when I simplify it, it would be a sub 1 n again. Oops. Let's go out of that box. Or a sub n sub n, and then I simplify it. Let's see, so I'd have 2.4 n 3 minus 2.4 would give me a positive 0.6. Am I right, guys? Check my work. Don't take my word for it. Is that what we get? Yes. All right. So here's my simplified formula, the 2.4n plus 0.6. All right, so now I'm going to use that formula in my sequence command. I'm telling the calculator to add 2.4 times n plus 0.6. That's my formula. My variable is n. I want to go ahead and start with the first term. And I honestly have no idea how long it will take me to find all my terms. So let's pick a big number like 30 again. All right, so let's look at my numbers. So I've got 12.6, 19.6, 27, 29.4, and 34. So let's see if we have a 12.6 here. Oh, there's a 12.6. Do we have 19.6? No, we have 19.8. So this one is not included. We have a 19.8, not a 19.6. Let's go ahead and check and verify that we have the other numbers though. We have a 27. Yep, there's our 27. There's our 29.4. And do we have a 34.2? And we have a 34.2. So awesome. The only one that's not included is this 19.6. So guys, I will show you how to use this sequence command to have the calculator give you all the terms in your sequence. It is so nice. It is the coolest thing in the world. All right, let's go. Essay writing contest. It seems like one of those where we're going to have like 10 different parts to it. All right, so an essay writing contest ranks the essays from 1 to 20. The prizes are 100, 97, 94, and so on. How much does the person writing the 13th essay receive? All right, let's go. Man, I keep getting into that. Let's go to our problems. Oh, looks like I just have 2 parts. So the first question in the calculator, it's going to tell you to create an expression to calculate piece of n, the amount of money awarded to the nth ranked essay, and then simplify your expression. So all I'm looking for is the sequence formula. We should be really, really, really good at finding the sequence formula by now. So to find a sub n, my first term is 100. My common difference, I'm decreasing by 3. So instead of a plus, it would be a minus 3. And then n minus 1. And of course, the problem tells me to simplify it. So I'm going to go ahead and simplify it. A sub n equals, let's see, negative 3n. I know that's going to be part of it, but then we'll have a plus sign. So right here, if you have negative 3 times negative 1, you get a positive 3. 100 plus 3 is 103. Okay? And I know a lot of people said, hey, what if we put the 103 up front? Can we do that? Yes, you can. If you want, you can do 103 minus 3n. Either way works. Either one is a simplified version. You're okay doing either way. All right, so now that we know the equation for the sequence, let's look. How much does the person writing the 13th essay receive? Okay, notice we don't have a calculator here. Let's go ahead and insert a calculator. And we want to use, whoops, not that one. We want to use this formula. So I'm going to just copy it. I know on your calculators, I don't think you can copy like I'm doing, and paste. And then all I need to do is figure out what number am I replacing this n with. Well, if I'm looking for the 13th place, then my n is just 13. So it's going to be times 13. Whoops, what happened? Okay, go ahead and do the time symbol or the parentheses, either one. So 100 minus 3 times 13. Okay, so the person in the 13th place gets $64. Are we good? All right, let's look at the next one, our marathon runner. Last year I decided I was going to get into shape and actually run a marathon. I got to the point where I could run about 10 miles, and I thought, never mind. Marathons are just too far. All right, so a marathon is 26.2 miles. A runner begins training by running 3 miles on the first day. He increases his distance by 0.8 miles each day thereafter. How many days does it take for him to run the distance of a marathon? So we're looking for the sequence, and we need to know how long it takes them to build up to running 26.2 miles in one day. Oh my gosh, that seems like a lot of work. Okay, so in the calculator, again, I'm breaking this down into steps. So the first step is figuring out your sequence formula. Okay, create an expression. Okay, again, that's your sequence or a formula or equation, whatever, to calculate m sub n, the amount of miles run each n days. Simplify your expression. So I know I've always been using a sub n, but because they're saying use m sub n, go ahead and do that. I probably will not count you off if you don't, but it's always a good habit. You might in the future have a teacher that's more picky than I am. All right, so let's see. The first day, a sub 1 is 3, and then we're increasing by 0.8 every time. Let's do 0.8 so we can see that point better. And then again, your n minus 1. All right. But let's simplify it. I know in class we have not spent a lot of time simplifying it. That's why we are simplifying every single one of these expressions. You need to get in the habit of doing that. All right. So my m sub n is going to equal 0.08 times n plus, what's 3 minus 0.8? 2.2, guys. Am I right? Check my work. Don't just take my word for it. Grab the calculator if you need to and check it. All right. So there's my formula. That's my sequence formula. Now I need to know when am I going to, in the sequence am I going to get to 26.2? Okay. So again, let me put a calculator in here. Let's go ahead and use that little sneaky sequence command in the calculator. And we're going to copy and paste our formula. Copy. Sorry, I know I'm cheating because you guys will not be able to do this on your calculator because you don't have the right click and left click on your mouse pad. All right, so 0.8n plus 2.2. Tell the calculator what your variable is. It's n. And I'm pretty sure he's not going to get started on the first day, but I don't want to mess up on my counting. So I'm going to go ahead and start at 1, and I have no idea how many days it's going to take him, so let's start with just putting a 30 in there. Okay, again, here's all our terms, and we have 1 day, 2 days, 3 days, 4 days, 5 days, 6, 7, 8, 9, 10, 11, 12 days, 13, 14, 15, 16, man, it's taken this guy a long time, 17, 18, 19, 20, 21, 22, 23, what number do we need to get to? 26.2. So we're at 23, 24, 25, 26, 27, 28, 29. Oh my heck. It took him 30 days to eventually build up to running 26.2 miles in a day. Holy cow. Am I going to do that? No, I'm far too lazy. All right, so I'm going to say it takes him 30 days. But what if I'm not 100% sure? You notice that I had to keep counting, and there were several times that I could have messed up. So let's say, hey, I want to just make sure that my answer is correct. Go ahead and plug it back into this formula. So 0.8 times 30 plus 2.2. Okay, where did the 30 come from? Well, I think my answer is 30, but I want to make sure if I plug it back into the equation that I do get 26.2. And so I'll plug that in, and indeed I get 26.2. All right, man, that's a lot of running. I don't even want to know how many days he ran in total. All right, let's look at the last problem, and I'm really hoping we get to this review question on Thursday. And again, I've broken it down in a couple problems. So, which of the following sequences are arithmetic? Is that the right way to pronounce it? For those sequences that are arithmetic, when it's a preposition, no, not preposition, what am I thinking? Oh my gosh, I'm getting a brain cramp. The abbreviation is ADJ, adjective. All right. When it's an adjective, I believe you pronounce it arithmetic. Arithmetic is the noun version of the word. Arithmetic is the adjective. I don't know. You know what? Somebody look it up. That's one of those questions where you really don't care about the answer, but it's kind of interesting to know. All right. So for those sequences that are arithmetic, identify D and write an expression for A sub n in terms of n, the term number. So guys, guess what? Pretty much every single question, you're going to need to know how to set up your sequence formula. So make sure you know how to do that. All right, so let's look at these sequences. Actually, we'll look at them over here. So 100, 98, 96, 94. What are you doing every time? Looks like you're decreasing by 2. Because we are decreasing by the same number every time, that is a arithmetic sequence. All right, let's look at the next one. 64, 32, 16, 8. Let's see, 16 to 8, you're reduced by 8. 32 to 16, nope, that's a decrease of 16. 64 minus 32 is a decrease of 32. So this is not an arithmetic sequence. Okay, look at the next one. So we're not going to check that one. That's the wrong one. And then 2 to the first power plus 1. Well, 2 to the first power, I'm just going to write down what those values are. 2 to the first power plus 1 gives you 3. And then 2 squared plus 1, so that's 4 plus 1 gives you 5. 2 to the third power is 8, right? 2 times 2 is 4, times 2 is 8, plus 1 is 9. And then 2 to the fourth power, so 8 times 2 is 16, plus 1 is 17. All right, so here we're increasing by 2, then we're increasing by 4, then we're increasing by 8. So because we are not increasing by the same number every time, then we are not, this is also is not a arithmetic sequence. So right there, we do not have a common difference, so that one is not correct. Now let's look at the last one. So 3/4 and 13 over 12, and then 17 over 12 and 7 over 4. Most of you are going to look at that and say, I have no idea what the common difference is. Well, pull up your calculator. Let's pull up a calculator and we can calculate this out. Okay, this is what we're working on. So in your calculator, we want to know what is 4/3, so 4 divided by 3 minus 13 divided by 12. Okay, negative 1/3. So it tells us that we're decreasing by a negative third. Now let's see what the difference is between 13 over 12 and 17 over 12. So I'm going to just type this in. 13 divided by 12 minus 17 divided by 12. Hey, look, we're decreasing by negative 1/3 again. And then what was our last term? Let's just verify. 17 over 12 minus 7 over 4. So let's check it. 17 over 12 minus 7/4. And we decrease by negative 13 again. So guess what? Right here, that is an arithmetic sequence. Even though it doesn't look like it, it is. Okay, so these are the two arithmetic sequences. Now the instructions say if it is an arithmetic sequence, identify D and find your arithmetic formula. Okay, so for 2.1, here we go. Here's our fractions. Identify D. Well, I already identified D over here. I found that it was -1/3. So down here, I'm just going to put, did it ask me for a number? Yeah, it just asked for a number. So -1 divided by 3. There we go. Now we want an expression in terms of n. Uh-oh, look what they said. Simplify your expression. All right, so let's do it. We can do a sub n. For our arithmetic formula, that's going to equal, our first term is 3/4. Our common difference is 1/3, so it's -1/3 divided by n minus 1. But we have to simplify our expression, and everybody's probably saying, oh my goodness, let it stop. Please, I don't want to. Pull up your formula again. Get a calculator. This time I'm just going to pull it up this way. I don't know what I'm doing. What am I doing? We need to distribute. So it looks like I'm adding 3/4 plus 1/3. So in your calculator, just do 3/4 plus 1/3. What do you get? 13/12. Woohoo, we found it. So our simplified version would be a sub n again. Aren't you guys glad you're going to have multiple choice questions? And we said, what did we find our answer? It always helps. 13/12. So 13 divided by 12 minus 1/3 times n. All right, so there's your simplified expression, your sequence formula. Next one. Okay, so again, remember we had two of them. So this one was a sequence, arithmetic sequence, and this one was the, arithmetic sequence. So now we're working on this one. We said we were reducing by 2 each time. So our common difference, we just need the number, was -2. And then the expression, let's see, a sub n, copy, paste. I hate pulling that up, so I'm going to do as many copying and pastes as I can. That's going to equal our first term, 100, minus 2, since that's our common difference, times n minus 1, close parentheses, and we need to simplify our expression. So a sub n equals, let's see, 100, so -2 times -1 is a +2, so we'll end up with 102 minus 2n, and remember, it will also equal, some of you are like, well, what if you put the -2 first? Will it still be right? Yes, you can do -2n plus 102. Either one of those will be the correct answer. All right, so we've gone through every single review question that we'll get through. Most of this you probably will see in class on Thursday. And if you need any more help, go to the textbook. Again, all these questions are straight out of the textbooks, pages 17 through 18. On Thursday, I will probably tell you if you need extra review, take those pages out, go home and practice with them. Your questions are pretty much going to be the same. I'm just changing your numbers. So I might change these numbers, and that's all I'm going to do. All right, I know this video was super long, but it will help you tremendously on your test. All right, good luck. I will see you guys Friday.